Welcome to this video about solving trig equations. So in this first example, we have the equation sine x plus square root of 2 is equal to negative sine x. Now this is an actual equation. Okay, so I can do whatever I want as long as I do the same thing on both sides of the equation. I can add sine x to both sides, which I'm going to go ahead and do. So then I've got 2 times sine x is, I'm going to subtract square root of 2 from both sides. Okay, so now I'll go ahead and just divide by 2. So we've got sine of x is equal to negative square root of 2 over 2. And we can think about the unit circle. The sine is negative in quadrants 3 and 4. And so we would have these angles right down here. Okay, so at 5 pi over 4 pi over 4 and at 7 pi over 4. Because sine is related to the y value of those points. So let's see, we've got 5 pi over 4. Okay, and x equals 7 pi over 4. But don't forget that from this point, I could just go around the circle once. I could just add 2 pi, or I could add another 2 pi. Okay, so any integer multiple of 2 pi would get us right back to that same spot who has a sine value of negative square root of 2 over 2. Okay, and likewise for this other point. Okay, so there's both of our solutions, and we've listed every single possible one that we could get there, where n is an integer, and so 2 pi n just represents any multiple of 2 pi. So let's see what this looks like when we graph. I'm going to graph the left-hand side, sine of x plus square root of 2, and I'm also going to graph the right-hand side, the opposite of sine of x. Now these points of intersection between our two graphs, those are where our two sides of the equation are equal, and so that's the x values. We have the first one at 5 pi over 4 and the next one at 7 pi over 4. Those are the x values that make this equation true. Okay, and then when we add from 5 pi over 4, if we added 2 pi, we would get an infinite number of other solutions, and from 7 pi over 4, if we added 2 pi, 1, 2, 3, 4 times, subtract 2 pi, we'll get all of the other solutions to the equation. So just be on the lookout if you're being asked to find all solutions and you're not being limited by some interval, like for example 0 to 2 pi, then just make sure that you're showing them all, and the way that we do that is by adding multiples of the period. In this next example, we're being asked to solve 3 tangent squared x minus 1 equals 0, but over the interval from 0 to 2 pi. So we don't have to have all infinite number of solutions, just only the solutions within that interval. Okay, so again, I'm noticing I'm being asked to solve an actual equation. I'm not being asked to verify an identity. When I'm solving an equation, I can do whatever I want as long as I do the same thing to both sides of the equation. So I'm going to go ahead and add 3 to both sides, and then, add 1 to both sides, divide through by 3. So we get tangent squared x is equal to 1/3, and we can take the square root of both sides. Just make sure that you remember to take the positive and negative, otherwise we'll lose track of half of our answers. Okay, square root of tangent squared, that is just tangent of x. So we get tangent of x is equal to either positive square root of 1 over square root of 3. We can break that down into square root of 1 over square root of 3. So that would be 1 over square root of 3. Rationalizing the denominator, we get square root of 3 over square root of 9, which is just 3. So we get either the positive or tangent of x is equal to the negative square root of 3 over 3. Now thinking about our unit circle, that happens at multiples of pi over 6. So tangent is positive at square root of 3 over 3 in quadrant 1, so at pi over 6, and also in quadrant 3, that would be at 7 pi over 6. Tangent is negative square root of 3 over 3 in quadrants 2, so that's at 5 pi over 6, and in quadrant 4, so that would be at 11 pi over 6. And we get to stop there with just those 4 solutions because we're being asked to solve over an interval, not find all possible infinite number of solutions. We're going to solve 10 sine squared x minus 7 sine x equals 6. The first thing I'm going to do, I'm noticing that squared term, and so I'm going to set this equal to 0, subtracting 6 from both sides. We get 10 sine squared x minus 7 sine x minus 6. And now I'm going to try and factor, let's see, if 10 sine squared, that can be 5 sine x times 2 sine of x. To get that 6 term, let's see, let's do 6 times 1. And I think if I do that positive, that negative, let's just double check by foiling it out. We'd get 10 sine squared x plus 5x minus 12. That's going to work. Okay, so we go through the process of factoring, and then we're going to use the zero product property, which sets each of those factors individually equal to 0. So we've got 5 sine x minus 6 equals 0, or 2 sine x plus 1 equals 0. And let's solve each of those. I'm going to add 6 to both sides, divide through by 5. That one, because 6/5 is bigger than 1, and the output for sine of any angle, the biggest it can get is 1. So that one has no solution. This other equation, let's see, subtracting 1 from both sides, we would get sine of x equals -1, dividing through by 2, we get sine of x equals -1/2. And that happens in 2 different places over this interval from 0 to 2 pi. Sine is negative in 2 different quadrants, 3 and 4, and those are at, let's see, 7 pi over 6 and 11 pi over 6. Okay, so we've found our 2 solutions. We know we're done. We don't have to find all infinite numbers because we're just going within that interval. In this example, we have more than one trig function. Notice that we have a sine squared, and we also have a cosine. So we need to figure out how to write this with only one trig function, and because cosine squared plus sine squared x equals 1, there's that Pythagorean identity. Sine squared x, if we subtract cosine squared from both sides, sine squared x is equal to 1 minus cosine squared x. So we're going to use that Pythagorean identity and replace our sine squared x with 1 minus cosine squared x. Okay, I'm just going to copy the rest of the equation down. So I have 2 times 1 minus cosine squared x plus cosine x minus 1 equals 0. Let's distribute our 2. So we get 2 minus 2 cosine squared x plus cosine of x minus 1 equals 0. I'm going to combine my numbers. So I have -2 cosine squared x plus cosine x and then plus 1. 2 minus 1 is 1, and that's equal to 0. We're going to have to factor this, and so I'm going to just divide everything by -1. So my leading coefficient is now a positive 2 times cosine squared x minus cosine of x minus 1 equals 0. And now we're ready to factor. Let's see, to get 2 cosine squared x, we would need to have 2 cosine x times 1 cosine x, or just plain cosine x. To get a -1, we need 1 times -1. We'll make that outer one negative, so when it gets multiplied by that 2 cosine x, we'll end up with that negative cosine x in the middle, which is what we want. Okay, once we've factored, we can use the zero product property, which allows us to set 2 cosine of x plus 1 equal to 0 and cosine of x minus 1 equal to 0. We'll solve both of those, subtracting 1 from both sides and dividing by 2, we get cosine of x equals -1/2, And this other one, if we add 1 to both sides, we get cosine of x equals 1. And thinking about the angle that has a cosine output of 1, that angle is 0. 2 pi does as well, but our interval includes 0 but does not include 2 pi. So we're good to go just listing 0. And again, thinking about our unit circle, cosine of x equals negative 1/2 in 2 places on the unit circle. Cosine is negative at in quadrants 2 and 3, and negative 1/2 at 2 pi over 3 and at 4 pi over 3. So we've got x equals 2 pi over 3, 4 pi over 3, and 0. In this last example, let's just look how to find approximate values using the calculator for solutions that are not on the unit circle. Okay, so I'm going to isolate my trig function, add 3 to both sides, divide through by 4, so I have cosine of x equals 3/4. Now we can take arc cosine of both sides, and so we get arc cosine of x, that simplifies down to just x, arc cosine of 3/4. We can pull out the calculator, just make sure you're in either degree mode or radian mode, depending what's given. All right, so arc cosine, and the way that we find that is to do, go to functions, and then type in arc cosine of 3/4, and we get 41.4. Okay, degrees, so that's great. We're not done though, because we need to find all the possible angles in that interval between 0 and 360. And so looking at our unit circle, think about the reference angles. There's going to be 4 different places on the circle that have that same reference angle of 41.4. There's one in quadrant 2. We would find that by taking 180 minus 41.4. That's in quadrant 2. In quadrant 3, if that little extra reference angle is 41.4, then we find the angle by taking 180 plus our reference angle. However, the one that we're looking for is in quadrant 4, because our cosine is positive 3/4, so it's a positive, and that happens in quadrants 1 and in quadrant 4. Okay, so the angle that we're looking for, we're going to find by taking 360 minus 41.4, and that gets us our second angle, which is 318.6. And that is done.